This week we're talking about where our data comes from. So last class we talked about how we can construct a sample that is representative of a population as a whole. And the idea is that if we ask the sample a question or run some experiment on this sample, then maybe we can get some information not only about the sample itself, but about the general population, which is what we're actually interested in. Today we're talking about observational studies, and on Friday we will be talking about experiments. And so these are the two different ways or two different structures that we can use these samples to give us some information about what the population is doing. Today we'll start off by talking about lurking and confounding variables, which have a sort of subtle distinction between the two. They're very similar ideas, and we just want to clarify that in the beginning. A lurking variable occurs when an apparent association between two variables, let's call them A and B, can really just be attributed to a third variable which affects both of them. And that's the important distinction here. So a common example for this would be the fact that ice cream sales and shark attacks are very strongly associated, right? So we might say that having too much ice cream is going to entice shark attacks. And there's a very strong association here. And what's really going on is that there is some third variable, and which really is dependent on what the weather is like that day, right? Summer months, you're going to have both more swimming, which is going to have more shark attacks, as well as more ice cream eating, right? So in that example, the shark attacks would be this third variable that is contributing to both of the explanatory variable and response variable. You could also switch this narrative and say that in response to shark attacks, people eat more ice cream. And the same sort of logic applies that, well, no, it's not because of the shark attacks that people eat more ice cream, it's because of the hot weather, and that's affecting both of them. So we'll say that a lurking variable occurs when an apparent association between two variables is due to a common response to some third variable. And again, the important distinction here is that this third variable is affecting both the explanatory variable and the response variable. Another example of this is the story of the kid riding in an airplane for the first time, and it's a very, a lot of turbulence, and looks over to a parent and says, I really wish that they would stop turning on the fasten seatbelt sign because it's causing the plane to be all bumpy. And obviously the third variable here is that, hey, there's actual turbulence outside, and that's causing both the seat to come on and the plane ride to be bumpy. Very similar to the lurking variable, but with a minor distinction, a confounding variable occurs when, again, we've got some potential relationship between A and B, but maybe in fact there is, again, some third variable which has at least some of an impact on our response variable, variable B. And the distinction here is that this is not a variable that's impacting the explanatory variable as well. It is only helping to impact the response variable. So an example of this would be if a store has some sale going on. So they say, all right, on Thursday this week, we're having a big blowout sale and everything's half off. And you compare the number of whatever is being sold, toaster ovens sold in the days before it to that day, and you see, hey, there's a big uptick, and there's a lot more people buying toaster ovens on that Thursday. Well, is that due to the sale, or was there potentially something else going on? Like maybe there was a, big festival in town, so there were more people on the streets, or maybe the weather was good or bad or whatever makes people want to buy toaster ovens. Just a confounding variable is going to be any other variable that is driving people to buy these toaster ovens. None of these things are going to be variables that are impacting the choice to have a sale, right? Having good weather on that day isn't what caused the sale, right? There's no link here. Instead, we just have this third variable that's impacting our response variable. Okay. Today we're talking about observational studies. Tomorrow or next time we're talking about experiments. But both of these are setups in which the investigators are trying to determine the nature of a relationship between two or more variables. So common examples of this would be smoking versus prevalence of lung cancer, or playing a musical instrument versus GPA, or dose level of a drug versus disease, or if you get some disease or not. So for any of these, we're interested in the relationship between the two. Like, is there some sort of causation going on? Is there, just what's the nature of this relationship? And so observational studies and experiments are the two main ways that we have of studying these things. The primary distinction between these two is that with an experiment, the people running the experiment take an active role in what the treatment or what choices the participants take. So maybe they are assigning a certain level or dosage of a drug, and then they're comparing, disease prevalence. In contrast, with an observational study, the people running the study take a much more hands-off approach. They're just observing what's happening and then drawing a conclusion from there. In general, experiments allow us to say more. We can actually determine some potential causality, but for many situations, they're less feasible or they're just not something that we can do. So instead, we're going to run an observational study, which is, like I said, the more hands-off approach. So some common examples would be, this smoking versus lung cancer. You can't tell the subjects of the study, hey, you need to smoke on this day, and then you need to not smoke on this day. Like, that's not something that you can actually control for, ethical reasons. Another one would often be playing a musical instrument when you're young. You're not going to take a group of kids and say, all right, this group is going to learn the violin and this group is not, and then we're going to compare their GPAs 10 years later, right? We're not going to affect people's lives that much. So instead of running an experiment where we're controlling these ideas or controlling these groups, we are doing an observational study where we just see what happens. All right, so the two main types of observational studies that we're going to talk about, the main distinction that we're going to draw is with retrospective versus prospective studies. And the idea is that a retrospective study happens entirely after the fact. So maybe we are going to look up some school records of comparing GPAs to whether or not they were in the band or orchestra. So a retrospective study happens after the fact. With a prospective study, the people running the study set things up beforehand. So they identify the different groups, they identify the candidates, or they identify the subjects early on, and potentially which group they're going to go into, and then 5 years later or what have you, then they go back and look at this. So a prospective study might happen if we were interested in this and we had our batch of kids who are entering, when you start playing an instrument, entering elementary school, where they're making this decision to play an instrument or not. We then recruit them for the study and then track their progress into the future. So that would be a prospective study. A retrospective study would be if we just now decided, hey, we wanted to know this, let's go back and look at school records. Cool. A major issue with these observational studies is that it can be difficult to account for lurking or confounding variables. Let's take the musical instrument and GPA example. It could be the case that parents who are more involved in their students' education also push them to to pick up an instrument. And so that parent being active in the education may also be boosting the GPA. So we may have a lurking variable that affects both of them. And with observational studies, if we can identify those lurking variables, we can account for them. Perhaps there's another column in our spreadsheet that is somehow measuring, parent attentiveness, maybe being in the PTA or, what have you. So it is possible to get around this problem of these lurking or confounding variables, confounding our conclusions. But the main problem with observational studies is that you can't always be sure that you got them all. There could always be, something else that you weren't really thinking of. And that's sort of where experiments come in. So observational studies are sort of all we have for a lot of situations. If we can't, for ethical reasons, take an active role in assigning participants to roles, then, all we have are observational studies. And they do give us information about this association. We just have to take that with a grain of salt that we weren't completely accounting for everything like we would with an experiment. More on experiments next time.